Okay, then slideshow. Here, okay, I can do it. Cool.
Awesome.
Good job on your presentation, Randy.
What?
Good job on your presentation. Yes, we know. We'll see if we can get through ours. I'll wait till exactly 2:30. Wow, people to come in. 2:31.
I'm sorry, man.
Put out the next. Or the how? Oh, it's stressful. The thing is, this is the third presentation today. So we'll see what we think. We have to get some water. Yes, how about you? I'm Stephen Lazar. Nice to meet you. We should stay there. So what's the time about that? So we want to trade. Are you guys good about
Life time.
Never know. That is How close is Eastman to Nashville?
5 hours.
Oh, that's not close. Can we get over there?
30 to 20.
Okay. Ah, okay. All right. Yeah, okay. Well, good afternoon, everyone. Thanks for coming and attending. I'm Steve Lazar, Business Development Manager for Atmosphere Optics, and I'll be presenting on Atmosphere's Fenceline system, real-time remote sensing open path technology for fenceline monitoring, along with lessons learned from applying that technology to California's AB 1617 and its implementation for South Coast Rule 1180. Thanks for coming. You didn't miss anything. So I'll briefly discuss Atmosphere's core competencies, then our experience and observation with the implementation of California's new regulations. Atmosphere is an advanced, innovative technology development company working in the field of air monitoring services worldwide. Our scientists played significant roles in developing US EPA methods TO16 and OTM10, and the relevant EU ASTM and IL technology and methods. We performed dozens of installations worldwide, including studies for industries in Texas, and hold several patents for our technology in the United States, Israel, and Europe. Atmosphere is the first commercial entity to receive ISO 17025 accreditation for remote sensing with US EPA method TO16. So Atmosphere provides advanced technology for total integration of Fenceline monitoring. Today, we're going to discuss the application of the Fenceline system to FTAR and UV DOAS OpenPath technology. Fenceline can support fixed installation in real-time of Fenceline monitoring systems, as well as it can be used as a data checker for post-analysis QA/QC. It can also be used for short-term projects and investigations from a mobile platform, trailer-mounted application, allowing for rapid response in investigations and studies without fixed installation requirements. So the Fenceline system delivers real-time data with the highest level of confidence, lower detection limits, real-time quality control to eliminate false positive and false negative data, and provides emission source location in real time. In other words, it's designed to tell you when an emission is occurring, identify the compounds emitted with absolute certainty, identifying dozens of compounds simultaneously. It will identify the location of the emission to allow for rapid remediation before it becomes a problem for the surrounding community, and it will quantify that emission. Fenceline applies proprietary algorithms to improve any spectral instrumentation. This example shows an FTIR. The same principle can be applied to UV DOAS. OpenPath FTIR essentially counts molecules. We shine a beam of infrared light to a highly polished gold retroreflector. Hi, thanks for coming. The beam then returns to the detector. This configuration, the monostatic configuration, was invented by one of Atmosphere's scientists, Dr. Robert Kagan. We utilized two laws of physics. First, we utilized the principles of Beer-Lambert's law, which tells us that absorbance equals a constant multiplied by the concentration and the path length. By measuring the absorbance and the path length, we can quantify hundreds of compounds, many of which to the sub-ppb level. Second, when excited by infrared light, each compound absorbs radiation in different parts of a spectrum that gives each compound a unique spectral signature. In other words, a spectral fingerprint. On the left, in red, we see the signature of benzene in IR, and on the right, in blue, we see the signature of benzene in UV. The strength of multispectral instruments is simultaneously identifying many compounds. The weakness of multispectral instruments is that unless you know how to correctly interpret the spectral data, false positives and false negative data can potentially be reported. Automation is the key to producing real-time data. So you must have good enough software to identify and quantify with absolute certainty. Using our proprietary algorithm, we can compare each spectrum to the NIST reference spectrum in real time for positive real-time identification. The strength of the Fenceline system is that we don't report numbers. Our software automatically compares the measured spectrum to the NIST or PNNL reference spectrum in real time. Example shows the spectrum for ethylene. Red is the reference spectrum and blue is the one we're measuring. If there's any question about the identification of the compound being reported, you can click on the spectrum yourself and see the spectral validation as shown. In this way, you can know for certain that this is the actual compound and not a false positive. The Atmosphere Fenceline technology is unique proprietary technology, and we hold patents all over the world. Our proprietary algorithm reduces optical and electronic noise, dramatically improving signal-to-noise ratio, allowing us to improve any spectral technology by a factor of 5 to 10, giving us the ability to measure in ppb and sub-ppb levels. You look puzzled. If you want to ask any questions, we're.
No.
That's okay. You're what?
No.
Okay, I'll keep going. The Fenceline's patented algorithm locates emission sources in real time, allowing you to determine where it is coming from inside or outside your facilities, facilitating repair and protecting health and safety at the plant and surrounding communication. This is done, and the surrounding community, I'm sorry. This is done with back triangulation. So here we see the plume, and with the wind, we get one cut point. The wind changes, the plume changes. With the wind, we get a second cut point, and we can triangulate that. The more instruments and retroreflectors we have, the more accurate we can determine where the source of the emission is coming from. We can find the source and display it in Google Maps so it is easily understood. Here you see a screenshot of how Fenceline displays an emission source. The brighter the color seen in the circle signifies the higher probability that the signal is coming from that area. While we can improve any spectral technology, our preference is to use the Bruker FTIR, the world's largest manufacturer of FTIR instruments, providing very robust instruments with the best optics and electronics and worldwide support. Bruker recognizes the benefits of the Fenceline algorithm and software and has selected Atmosphere Optics to implement their solutions. I trust based on the presentation thus far, you can see how the Fenceline system serves to protect the environment and improve health and safety, with applications to the stakeholders shown on this slide. We'll now move to the second half of our presentation, discussing how this technology has been applied successfully to recent changes in legislation and some of the pitfalls of this legislation that we've learned in the process. We're all familiar with the federal benzene rule. And California implemented AB 1647, allowing each county to write its own real-time Fenceline rule. Bay Area wrote Regulation 12, Rule 15, and South Coast Rule 1180, requiring multiple compounds to be measured at the Fenceline and reported to the public in real time on a publicly accessed web page with quality assurance to provide confidence in the data. The first question is, who should monitor? California applied these rules to 10 of their largest refineries, those producing above 40 barrels per day. This is a good start, but the data tells us that the emissions are more related to effective controls than production size. In reviewing the reported emissions data, we see that the larger refineries tend to invest more money in controls and operate with lower emissions than many smaller refineries who invest less. The next question is which chemicals should be monitored? In 2017, the Office of Environmental Health and Hazard Assessment, OEA, along with California, wrote this document, The Analysis of Chemical Emissions and Health Effects, identifying 188 chemicals that could be emitted from a refinery, and for most of them providing recommended exposure limits, RELs, for these chemicals for acute exposure for a 1-hour average, along with exposure limits for 8-hour averages and 1-year averages. South Coast AQMD chose 18 compounds and Bay Area just 10. This is important to note because the purpose of the program is to provide notification to the public when safety limits are exceeded. This is the list of chemicals that must be monitored per the South Coast Rule 1180. One of the key intent of the rules is to notify the public in real time when there are exceedances for hazardous chemicals. Therefore, measurement sensitivity or measurement detection limit must be less than the alerting threshold. Using Atmosphere's Fenceline system, one measurement system can achieve detection limits below the recommended OEA safety threshold for almost all the compounds. The exceptions are H2S and black carbon, for which we use point monitors. There is a big question that the California regulations did not answer, and that is, how can we measure total VOCs, or non-methane hydrocarbons in refineries, with an open path system? Comparing to the OEA thresholds, the compounds being focused on by the California regulations, benzene and BTEX, actually represent a small fraction of the total emissions from a refinery. In fact, benzene is less than 1% of the emissions and rarely found, while the sum of all the California regulated compounds represent less than 10% of the total emissions from refineries. Some look at the California regulated compounds as a surrogate for the total emissions, but the unregulated total alkanes, such as butane, oxane, and hexane, etc., represent more than 60% of the total VOCs from refineries, and this is based on reported data. These are actual measurements with Atmosphere's Fenceline system. On the left, we can see that benzene is usually below the 1 ppb detection limit. When there's a major leak or accident, then the benzene far exceeds the detection limit. On the right, total alkane concentrations at the refinery lines, fence lines, range from 50 to 500 ppb. In the case of a malfunction, total alkane concentrations can jump to ppm or tens of ppm levels. While many regulators believe benzene is a surrogate which can be used to measure emissions, when actually measured, we can see that it is not an indicator of any emission other than benzene. Given that the total alkanes are the major emissions from the refinery, how can we measure them? Every compound that has a CH bond absorbs light in the CH stretch. You can see that in the spectral signature in the picture on the right. We can't distinguish the individual compounds because the shapes are too similar, but we can distinguish them from other compounds and measure them as a composition, which we call total alkanes. This is documented in an EPA procedure developed by Atmosphere scientists and accepted by the EPA as a document measuring in ppbs. However, because total alkanes is a compilation of compounds, molecular weight must be calculated and reported with total alkane concentration to become meaningful data. Fenceline system has the ability to report molecular weight, which you can see in the second red circle. Find that second red circle. There we go. Okay. Without determining molecular weight, you cannot do mass balances or flux measurements. In other words, you cannot convert ppb into micrograms per liter. I'm about to show you an animated film, a short animated film that was an actual installation that was designed and installed by Atmosphere Optics to comply with South Coast Rule 1180. And what do you know? We have sound. I was worried about that. Each instrument cabinet has an open path FTIR on a pan and tilt auto positioner that can accurately shoot the beam in several directions surrounding the refinery with an optical fence and point monitors for black carbon and H2S. This installation also includes a UV-DOAS optical system because the regulator thought it was necessary to measure benzene at the required limit. However, in actual practice, we have found operating in the field that the Fenceline system can achieve the required detection limit with FTIR alone. The Fenceline system identifies a compound and its emission source. I'll wait before I tell you that part. I'll get a little further along. The animation looks a little bit like Mad Max and the Thunderdome because they didn't want us to actually. Anyways, the Fenceline system identifies a compound and its emission source. In this case, what you just saw is it's coming from outside the refinery, impacting its Fenceline measurements. So we were able to tell the operator that it wasn't coming from on site. I was going to say it looks a little bit like Mad Max and the Thunderdome because the client didn't want us to actually show what the actual refinery looked like. All the refineries required for Rule 1180 implemented Fenceline monitoring system and a website available to the public. This gave the public, and particularly communities surrounding refineries, for the first time, the ability to see emissions in real time, along with alerts when thresholds were exceeded. However, the refineries monitored in the South Coast District are producing more than 30 million data points required to the public each quarter. The question is, how can we reliably do quality assurance on that amount of data? We cannot rely on chemists, for that is physically not possible. It must be automated. What this regulation also allowed us to do was to compare data from dozens of systems from a variety of manufacturers and service providers, all working towards the same objectives. Each refinery reported data to its public website in real time, summarized in this table, number 7. Is the refinery using Atmosphere's, number 7 is the refinery using Atmosphere's Fenceline system. However, there was no uniformity in how the data was presented. And for the first quarter of 2020, only 2 of the 7 refineries achieved detection limits below the recommended exposure limit, or REL. Most failed required detection limits for acrolein, a very dangerous compound, and another 2 took over 6 months to issue a quarterly report. Having the ability to accomplish real-time data validation, only the Fenceline installation was able to issue the quarterly report on time for the first quarter and achieved all the MDLs. For the sake of public safety, the RELs can and must be achieved, and quarterly reports should be available on time. Also important is that there is no uniformity on how total VOCs are measured, so data and safety cannot be compared between refineries. Most recently, we've seen improvement with 6 out of the 7 issuing the reports on time. Technology should be selected that will measure below the required threshold today and be low enough to stand in the regulation in the future, should they be lowered. Only the Fenceline system will stand within the required thresholds without the need for UV DOAS. Vendors A, B, and C could not measure the benzene without adding a UV DOAS instrument, and for toluene and xylene, any open path FTIR is better at looking at the AWEA thresholds that are high and can saturate the detector when using UV DOAS. Only a good FTIR system and a good algorithm like Atmosphere's Fenceline, UV DOAS becomes redundant. The Atmosphere Fenceline system had far superior detection limits for almost all the required compounds. These are the alerts reported to the public in real time and reported in the quarterly report after QA. Detecting these three compounds in such high concentrations is unrealistic and could potentially be false. I've never seen them so high and would not be willing to report those concentrations to the public without further scrutiny with real-time spectral validation. It's bad for the brand name, carries with it the risk of litigation and an unnecessary waste of resources and time to try to find problems that may not exist. Most recently, we are seeing fewer higher concentrations and alerts in this range. In fact, very few alerts at all. So with very few alerts at all, our speculation is that quality assurance procedures were tightened to reduce false positives. However, without spectral validation, it's also possible that now false negative data is being reported. Formaldehyde concentrations worldwide have never been reported higher than 80 ppb. Therefore, reporting 600 ppb cannot be realistic. That alone tells us that these refineries most likely reported false positives. Here we see in our quarterly report the formaldehyde spectra compared in real time to the NIST reference spectra. The only way to be certain that false positives are not reported is to do real-time spectral validation. Comparing the measured compound to the NIST reference spectrum in an appropriate way and should have the ability to see it in real time with spectral validation. If the refineries in the previous slide reported such high concentrations had the ability to do spectral validation, I'm almost certain that those data points would have been flagged as false positives and not reported to the public. Real-time spectral validation prevents false positives in real time and in the quarterly report. With the Fenceline system, every concentration reported in an instant can be compared to the reference spectrum, preventing the report of false positive results in near real time, as opposed to waiting for the data to be evaluated and put in a quarterly report. Let's look at the data from another refinery's quarterly report. The detection limit for benzene using UV DOAS was reported at 1 to 3.5 ppb, not better than the FTIR. The acrolein detection limit was 27 times the AWEA threshold. In other words, the analyzer did not produce meaningful data for acrolein. Formaldehyde concentrations were reported at 613 ppb, more than 13 times the AWEA threshold. We believe this could very well be a false positive. Let's look at more data from a refinery's quarterly report. At this refinery, there are two different equipment providers and two different service providers. You can see in the picture that one provider on the south fence line detected ammonia on all paths. But on the north fence line, where there is a different provider, no ammonia was detected. In the quarterly report for the quarter number 2, one provider found acrolein at almost 3 times the AWEA threshold, while the other didn't see it at all. Even more surprising is that one of the service providers finds all of the compounds and most of the time he finds ammonia. In addition, their data shows a lot of VOCs going out of the refinery. The other service provider almost never detected anything and shows almost no VOCs going out of the refinery. At least one of them must be incorrect, making the data questionable. One service provider found ammonia over 93% of the time, while the other never detected it, with similar results for the rest of the compounds. This leads us to conclude that real-time QA/QC should be implemented. Then we thought to take the data from a few refineries and combine them together with wind direction for the last quarter. The compound that exceeded most of the time was hydrogen sulfide. When the orange refinery had high concentration, the wind was blowing from the east. When the pink one had high concentration, the wind was blowing from a north vector. And when the green had high concentration, the wind was blowing from the south. Looking back at the cut point, or the back triangulation of the winds, we can find the source and see that it is not in any of the refineries, but between the refineries. Using satellite technology on Google Maps, using satellite technology on the Google map, we can look at the area and find two yellow dots at the suspected location. As we know, sulfur is yellow, so we suspect that this is the source of the H2S exceedance and not necessarily coming from the refineries that were reported to the public.
Look on Google Maps, where is it coming from?
Right, it's not within the refinery, that's the point. It's coming from the yellow sulfur pile.
It's a sulfur manufacturers. Hydrochloric acids.
So the point is that the refinery may think that they have H2S when it's actually being blown into the refinery from the sulfur pile. So, lessons learned and recommendations. The ability to determine the origin of fenceline detections and real-time source location can be obtained at least at the facility level. Most refinery emissions are total VOCs or alkanes and should be a key measurement parameter. Benzene, the compound of primary concern to regulators, is rarely found and reported above 1 to 3 ppb, therefore cannot be a good surrogate for refinery emissions. Based on field reported data, UV DOS does not provide better detection limits than a good FTIR using a good algorithm. Automatic quality assurance, including spectral validation, should be used to provide high confidence data to the public when looking at millions of data points, especially when it is required to be reported in real time. Fenceline monitoring can work and report data to the public with more than a 90% completeness. Contaminants measured should be expanded to a more meaningful list, consistent from area to area to protect health and safety. For example, in California, South Coast and Bay Area are reporting vastly different lists. There should be one website that presents data from all the refineries with one database that should be available to the public, not the republic, the public. The website should have the ability to use the data from all the sites to clearly present the air pollution picture. The website should have the ability to semi-automatically validate from all the sites. With the full implementation of Rule 1180, the public will have a good and reliable alert system in case of an emergency. When possible, it is better to follow the approved method technology, US EPA TO16 and OTM10. It is recommended to define a uniform method for measuring total non-methane VOCs in refineries as total alkane based on EPA protocols. It's also recommended to define a uniform method for measuring sensitivity MDLs of the measurement, the detection limit. As a final slide, I'll summarize what we learned about Atmosphere's defense line system. The defense line system provides online QA/QC, including online spectral validation. We have online automatic source location, unprecedented detection limits, PPB and sub-PPB levels, long list of compounds, including total VOCs as total alkane, no need for UV DOAS, one instrument can measure them all, friendly and easy user interface, 24/7 technical and scientific support. And this technology is important when industry is located adjacent to communities. So I hope you enjoyed the presentation. I have a couple more slides to conclude it. So as I mentioned at the beginning, I'm Steve Lazar. In addition to what I've done for the scientific community, I'm also known for my hats. And I'm known for my work as a rock and roll star. So as that, I've written the Atmosphere theme song, which summarizes what you've heard in this presentation.
Atmosphere graphics, and I'm here to tell you that you have the right to real-time, multi-sense, efficient data that you can have 100% confidence is accurate and precise. So come on, everyone, sing with me.
With backup vocals by our CEO, Gilad Shpitzer. So don't give up the fight. You have the right for real-time spectral validation and real-time source location and the lowest detection limits possible. So thank you very much. Gilad Shpitzer is also here. As I mentioned, he's our CEO. We have a booth in the first aisle, and we'd love to talk to all of you. And I finished a little bit early, so I tend to talk fast. We have time for some questions. Yes.
You mentioned how much. Are you talking in concentration or are you talking as source?
Well, we quantitate in PPB and sub-PPB levels. We can also determine flux because we measure molecular weight.
We're talking about grams per second. Take the concentration, multiply it by the weight vector, so you will have 10 gram per second. How much gram per second? Source.
Thanks. Any other questions, comments?
Who wrote the song? What is the origin?
Well, we borrowed it from Bob Marley, but but we did write the lyrics ourselves.
You said that the system, you guys don't alert the public, right? It would just be up to the refineries to alert on the public.
But we designed the website for the refineries. And so in combination with the requirements of the regulator, the refinery can determine which data is put on the public website. They have their own website, which contains far more information and many more compounds for their own information. But most refineries tend to report simply what's required by the regulation. And that's done in real time.
Regulation in California says that you must alert public places. So the system got the capability to alert 10,000 people in a second. Mobile phone emails.
Yeah. So for example, I'm signed up for the alerts. And so when there is an alert, I receive an email message that there's an alert. And then atmosphere scientists are constantly watching that 24/7 and do additional review when there's an alert. And most of the time we find that it's actually not coming from the refinery, or we can tell the refinery approximately where it's coming from so they can fix it. And then another email message goes out when the exceedance is then eliminated. This can also go out via text messages to staff at the refinery to their mobile phones so that they can act on it quickly. Okay, please visit us in the exhibit hall and enjoy the rest of the conference. Thank you very much. Okay, how do I close my presentation? That's what I'm trying to do. There we go. That's so great.
I was gonna. Oh, is this your?
I have my presentation on Flash Drive. What do you do?
This is your computer? Or no?
No,
Okay.
seriously.
So what do you guys do?
We're in the opacity business, so we do digital cameras and then opacity.
Okay.
So